We finally are going to get to do some maybe borderline real chemistry today. So we're going to actually look at isotopes and atomic masses of elements. So the atomic number is the number of protons in the nucleus of each atom of that element. If the number of protons changes, so that means if we go from like 1 proton to 3 proton, we also change which element we're working with. So if you look at a periodic table, if your chemistry teacher was prepared and had one for you guys, if you look at each box, you're going to see the symbol. So in this case, we're looking at tin. And then there will be a whole number either at the top or on the bottom. And so for tin, what do we have for the whole number in the box? 50. Do you just have that memorized? Did somebody say that over there?
Oh, I have it written down.
Oh, because you went through already? Well, that's fine. Prepared is not necessarily cheating. So the atomic number of tin is 50. So that should indicate to you that tin has 50 protons. That will also indicate to you that in an atom of tin, there will be 50 electrons. However, if it is not an atom of tin, if it's an ion, this does not hold true. The electron count will change. So the only hard and fast, always, always, and forever, ever fact that we can get from this atomic number is the number of protons. So then looking at potassium, how many protons would potassium have? 19. Glenville, you found it? Yes. Okay. Not going to lie, I totally just did this with 7th graders today. So then we move to the mass number. The mass number is the combination of the total protons plus the number of neutrons. So this is going to be the decimal number on the periodic table. So looking at gold, AU, what would be the mass number? I don't have this one memorized. 196.97. Okay. 67? No, it's 97. Okay, so for our purposes, current purposes, this will change in a couple weeks. This mass number will need to get rounded to the nearest whole number. So in this case, this will get rounded to 197. So let's look at figuring out how many neutrons are in an atom of zinc. So zinc, in order to answer this, you need to know 2 things. The first is you need to know the atomic number and the atomic mass of zinc. So what is our atomic number for zinc? 30. And the atomic mass for zinc? 65.39, you said? Okay. What does that 65 round to? 65, duh, I just said it. So then it's just a simple subtraction. You take your 65 minus the number of protons, which is 30, and we are left with 35 neutrons. So on the periodic table, the atomic mass, it's not necessarily in grams. It is in something called the atomic mass unit. It's abbreviated AMU, and this is the mass equal to 1/12 of the mass of a carbon atom. The only reason to know that definition would be for the test. It's not something that is pertinent to your success in this class, I guess. So there are a couple different ways to write this information about each atom. You can do it this way. And so we obviously have the symbol. The top number is the atomic mass. And the bottom number is the atomic number. From here, you should be able to figure out the number of protons, the number of neutrons, and since we're dealing with atoms, you should be able to figure out the number of electrons. All right, in this second way of writing these symbols, we have the full name of the element this time, and here it just tells us the atomic mass. So you would, if you don't have already memorized, which eventually you'll probably have a bunch of these memorized, their atomic numbers you'd have to look up on the periodic table to do any sort of calculations or get any kind of information. So then the little hiccup here is with isotopes. Isotopes are atoms that have the same number of protons but differ in the number of neutrons. So for example, carbon has 3 different isotopes: carbon 12, carbon 13, and carbon 14. So with each one of these carbon isotopes, we have a different number of neutrons. So if we look at this, carbon 12, what is the atomic number for carbon? 6, very good. So in carbon 12, how many neutrons does it have? 6. You just do the subtraction to get 6. In carbon 13, we still have 6 protons. So how many neutrons does it have? 7. Good. And in carbon 14, still has 6 protons, so we have 8 neutrons. So each one of these isotopes, as we add a neutron, the overall mass will increase. So when we get the decimal number for atomic mass on the periodic table, it is the average of all of the isotopes combined, the average mass of all of the isotopes. So that's why most elements will have a decimal number for that. Does that make sense? Head nods, please. So moving on then, chemical reactivity, so how reactive an element is not affected by the presence or absence of isotopes. Chemical reactivity is due to the presence of protons and electrons, and predominantly electrons. So we're not really working with that quite yet. A nuclide is the nucleus of a given isotope of an element. It's just a fun vocab word that I feel like nobody uses, but we'll just highlight it anyways. So let's practice a couple of these. How many protons and neutrons and electrons are present in each of these nuclides? So protons, neutrons, and electrons for each of these. Starting with iron, how many protons will we have?
26.
26? Do we agree or disagree? Agree? Okay, good. How many neutrons will we get? 30. And how many electrons? 26. Cora, you're good with that? Okay, just making sure. Iodine, how many protons? This one you have to look up on the periodic table because we are not given the atomic number. What is the atomic number? 53, good. So how many protons will iodine have? 53. How many neutrons? 74. And electrons, 53. And last one, phosphorus. How many protons?
15.
Neutrons?
16.
Electrons? 15. Good. Questions on those? Pretty solid with the arithmetic. All right. The last and slightly more complicated of the problems is that isotopes do not occur in the same abundance. So like with the carbon example, the 3 isotopes, it's not 33.33% of carbon 12, 33.33% of carbon 13, and 33.33% of carbon 14. They occur in different amounts. And so in order to correctly calculate the average, you need to take their abundances into account. So with this sample problem, we're working with chlorine. And so this will be chlorine 35 and then chlorine 37. It tells you the atomic mass of each and then the abundance. So for chlorine 35, if we want to figure out the percent of its, in order to figure out the average, all you do is you take the mass for that particular isotope, 34.969, and multiply it by its percentage, but you need to put the percent into decimal form. When you do this arithmetic, what do we get? Cora, what it? 26.496. Let's keep the extended decimals here because we should always only round right at the end. So then do the same process for chlorine 37. Your given mass here is 36.966. Times it by the percentage. Remember to take the percentage into decimal form. And what do we get here with the arithmetic? All right, what did you get? 8.956. So then to get the average mass that incorporates the abundance of both isotopes and the mass of each isotopes, you simply add all of your isotope masses together. And we would get 35.45 AMU.